Greetings, fellow Meccas. Today, we'll be solving a welfare problem. The problem given inverse demand P equals 69 minus 2Q, inverse supply P equals 9 plus 3Q. Part A. Competitive market. Calculate the equilibrium price and quantity. Part B. The negative health effects using diet is measured to be MEC, or marginal external costs, equal to 5Q. 1. Calculate the socially efficient level of dye. 2. Graph Part A and Part B1. Part 3. Calculate the change in total welfare when the equilibrium moves from competitive to socially efficient one. Now pause this video, take a few minutes, and solve this problem. Welcome back. Hopefully you were able to solve this problem. Now, let's solve this together. So part A, competitive market, calculate the equilibrium price and quantity. So in a competitive market, to find the equilibrium price and quantity, we need to set our marginal private cost equal to our marginal private benefit. We are given an inverse demand of P equals 69 minus 2Q, and that translates to our marginal private benefit. So marginal private benefit of 69 minus 2Q, and we have a marginal private cost of 9 plus 3Q, which translates to our marginal private benefit. So 9 plus 3Q. Now we need to solve for Q, and to do that, we can add 2Q to both sides and subtract 9 to both sides to get 5Q is equal to 60. Then we can divide by 5 on both sides, and we get a QC equal to 12. And then to find our price, or equilibrium price, or PC, we can either plug 12 into our marginal private cost or marginal private benefit. I'm going to plug it into our marginal private cost. So we're going to get a value of 9 plus 3 times 12. And this is going to be equal to 9 plus 36. And our PC is going to be equal to 45. So at a competitive market, our equilibrium price is 45 and our equilibrium quantity is 12. Part B. The negative health effects using dye is measured to be MEC equal to 5Q. Calculate the socially efficient level of dye. To do this, we need to set our marginal social benefit equal to our marginal social cost. Our marginal social benefit is equal to, so marginal social benefit is equal to our marginal private benefit. And if we remember from above, our marginal private benefit was 69 minus 2Q, or our inverse demand. Our marginal social cost, this is going to be equal to our marginal private cost plus our marginal external cost. This is going to be equal to our inverse supply from above. So we get 9 plus 3q plus our marginal external cost, which is 5q. So then our marginal social cost is 9 plus 8q. So now we set our marginal social benefit equal to our marginal social cost. So we get 9 plus 8q, marginal social cost, equal to our marginal social benefit, 69 minus 2q. We can now solve for q. So we add 2q's to both sides and subtract 9 on both sides. We get 10q is equal to 60 divided by 10. We get a, 1 second. We'll get QE, a quantity at efficient equilibrium, to be 6. And now we can plug in 6 to either marginal social benefit or marginal social costs. Let's just plug in 6 to our marginal social costs. So PE is going to be equal to 9 plus 8 times 6. And this is going to be equal to 9 plus 48. So this is going to be equal to 57. So a PE, a price at efficient equilibrium, will be 57, and our quantity at efficient equilibrium will be 6. Now, graph part A and part B1. So to do that, let's first draw some lines. Alright, so on our x-axis we're going to have quantity, and on our y-axis we're going to have price. We're given an inverse demand. This is our marginal private benefit, which is also equal to our marginal social benefit. And we're given a marginal private benefit that is positive, and a marginal social cost that is also positive. So this is our marginal private cost, and this is our marginal social costs. And we know that a competitive equilibrium, the marginal private cost is where it intersects on marginal private benefit. So this point right here is going to be a QC, which is going to be equal to 12. And this point right here is going to be equal to a PC, which is going to be equal to 45. And this point right here, where marginal social cost intersects on marginal social benefit, is our efficient equilibrium. So this right here is going to be a QE, which is going to be equal to 6. And this point right here is going to be a PE, which is going to be equal to 57. And then if we take this QC dotted line and we extend it vertically to this point right here, so we get labeled as a C, E, B. This triangle right here will be our change in welfare. Change in welfare. And let's see. I believe that is it for this part. Yeah, looks good to me. Alright, so now calculate the change in total welfare when the equilibrium moves from competitive to socially efficient one. So to do that, that is our triangle EBC. So we need to calculate the area of EBC, and to do that, to calculate the area of triangle is just 1/2 base times height. So we know it's going to be 1/2. The height of it is just 12 minus 6, so that gives us 6. And our height will be, well, we need to find this point B, the price of point B. To do that, we plug in 12 into our marginal social cost equation, which was 9 plus 8q. So marginal social costs at 12, at a quantity of 12, we get 9 plus 8 times 12, which gives us 9 plus 96. Let's see, 80, 96, yeah. So this should be equal to 9 plus, that is 105. So then we get 105 minus 45, which gives us 60, which is going to be equal to 60. So then we get a change in welfare, is equal to 1/2 6 times 60, which is going to be equal to, let's see, 360 and divide that in half, that's 180. 180 as our answer to part C. And that is the solution to the problem. I hope this video helped. If it did, please consider subscribing.